Dr. Camille Maumet, who is a research scientist in neuroinformatics at INRIA in France, where her research focuses on neuroimaging reproducibility, particularly the variability of analytical pipelines and their impact on our ability to reuse and use brain imaging datasets. So today, Camille will be talking on reusing neuroimaging derived data. Thank you so much. Over to you.
Thank you very much, Amy. So I'm going to try and share my slides. Is that working okay?
Yes, looks great.
Fantastic. Thank you so much. So hi, everyone. Very excited to be here today. So in this talk, I'm going to focus on the question of, can't see my video anymore. Okay. Trying again. Okay, we started again. It's better. So I'm going to talk about reusing derived data, and we'll get later on a little bit more on what we might want to do that. But before I get started, I want to focus on one point. So when we talk about sharing data, we often refer to the FAIR principle, which stands for findable, accessible, interoperable, and reusable. Well, we'll talk about this more later. And we often focus on technical solutions. So do we have standards? Do we have databases, good practices? And this is a lot of what will be covered in this talk. But before I start, I want to emphasize that FAIR neuroimaging, as part of open science in general, is also something that is going to provide a culture change, is actually providing a culture change in the research community. So basically by sharing data, the idea is that other people are going to be able to reuse it. And by doing so, we're creating more opportunities to interact between members of the research community. This can be through data, through code, and so on. And by having these opportunities to interact, often it's changing the way we actually do research, because we might get opportunities to discuss ideas earlier on, or to hear about different efforts that might be complementary to what we're doing, and so on. And so I really want to emphasize that first, basically that this idea of data sharing, FAIR neuroimaging, even though we talk a lot about the technical solution, is also about the people within the community and the changes create for them to for us to do research. And so, but going back to our typical study, MRI study. So typically how it works is as follows. We start with the phase of acquisition. So typically using an imaging instrument. So in my case, it's a lot MRI in its brain images. So my examples are drawn from that. We typically have a phase of data preparation. So this could include motion correction, segmentation, putting all the brains into a standardized space, and so on. And we do get some derived data. So I was talking about derived data in the title of my talk. The space of derived data is extremely big, can have many different forms. But then finally, we get some measurements we are interested in. And through statistical analysis, we get our final results. We do answer our research question. Typically, what is shared with the research community, if we get lucky, is a scientific publication. And of course, in recent years, there have been increased effort to first make these publications open to all. And here I've outlined a number of repositories, either institutional or preprint servers, where these can be deposited for free, both for the readers, but also for the people sharing their papers, the authors. So that's one aspect of sharing research products in relation to our MRI studies. But as people realized that there was a difficulty to reproduce results, findings that were proposed in the literature, basically there was this idea that maybe we should share more than just the research paper. And so the community initially, and then the funders later on, started to focus on how we can actually share the data that were in support of our research study. And so when we want to share our data, first we need to make a package with them, and then we need to find a home. So there are a number of homes right now, including OpenNeuro, XNet Central, Loris, Chat is another example. And I've put the Dundas repository here as well, which is institutional, but lets you do this type of data sharing. And what's really nice is that now data sharing has been going on for some time, and not only in the brain imaging or MRI community, but more broadly. And we have those first principles that guide us, provide a guide as to how we should do that so that the data is actually useful for other researchers. And so I'm going to get a bit more into detail. So the first letter in FAIR is F. For findable. So the idea of findable is very simple. It's the fact that we can actually search for open or shared data sets in a repository or beyond. So it's the idea of having somewhere a catalog that will let us, okay, I want to find some data that will help me answer my problem. Where can I find it? So that's the question of findability. Then there is the accessibility. Once I know that there is a data set, can I actually go and download it? So accessibility can be either through direct download, that's what you would see on OpenNeuro, for instance, or after signing a data user agreement. And this is what we're going to typically find for repositories that are based in Europe because of the GDPR, that basically is a European regulation that focuses on data privacy of the participants and that won't let us share data sets openly on the web, but makes it possible through agreement, checking that the people who download are actually, for instance, researchers, that they won't try to de-anonymize and so on, taking a number of steps to ensure that the privacy of the participants will be respected. Then we arrive to the third letter, I, that stands for interoperable. So what do we actually mean by interoperable? Well, basically the idea is to find a common language. So we have our data, can be on a database, on the server, maybe on your local machine. We want to package it so that we can send it to other databases. And the idea of interoperability is that we have one standardized way to represent our data, and then it can be understood by any type of repository or any type of, I don't know, pipeline that might want to reuse this data. So that's really about having a common language. And in the brain imaging community, we are lucky to have BIDS. But I won't give much information about BIDS because Patricia will be speaking about this just after in her talk. But very shortly, the idea of BIDS is to provide conventions for naming, file naming, folder naming, and metadata files about a brain imaging experiment. And so here, we have our package, so BID acts as a common language that can be used between different tools. And then the last letter is reusable, and this is extremely important. And this is about the type of metadata that were shared. So what's really nice about BIDS is that when it was built, the idea was to include just enough metadata that would be mandatory to make it possible to reprocess the data afterwards. So I think just to illustrate a good example of that are the onsets of the task in task fMRI experiments. Those are typically not conveyed within our NIFTs or within our DICOM files, and this is really something that BIDS has put next to the images. Yet this is crucial information if we want to process the task fMRI data. And so here we go, we have our FAIR data set, we have our principle that lets us have a good understanding of what are good practices if we want to be able to share data. So we've talked about sharing our raw data here, so we can package it and then put it into a dedicated repository. Then there is one first type of derived data, which are the result of our analysis. And here again, we do realize that conveying only result through a research paper, we provide a very limited view of actually what our results were. So for instance, in task fMRI, we might have clusters. So you might have a 2D image of maybe a slice or a couple of slices, but it's really hard to understand precisely where that location is, where does it stop, what happens in the slice we actually don't see. And so here again, just like we've done for raw data, we can focus on the FAIR principle. So there is one repository which is called neuroimaging that is dedicated to the case of task fMRI statistic maps. So that makes our maps both findable, we can search on neuroimaging, and accessible. So here's through direct download. And then there is the question of interoperability and reusability. And for that, there is a dedicated standard, which is called NIDM results. And the idea of NIDM results is that we're going to share important pieces of metadata. So these include maybe the threshold that was used for statistical inference, but also your design matrix, but also those images that basically describe the experiment. So the statistic maps, of course, but also the contrast map, the parameter estimates corresponding to the different regressors, and so on. And so there are exporters for NIDM results, and this can be imported into neuroimaging. And again, we've gone through the full circle of FAIR, findable, accessible, interoperable, reusable, and here our standard is NIDM results. So here in our pipeline, we can again share our results and put them into a dedicated repository. But then there is the more difficult question of sharing the derived data that are here in the middle. So we might want to ask ourselves, why is this important? Well, basically, sharing raw data was a great first step so that other people could check our results, like for question of transparency. But the idea ultimately is that also other people, researchers, scientists in the community are going to be able to reuse their data to answer new research questions. And with data sets that are increasingly big, basically, it doesn't make much sense for every researcher who wants to reuse the data to redo this phase of data preparation again and again and again. And so we can easily see that there would be interest in sharing derived data, being maybe just the pre-processed data, or at a level that is that the researcher think is best suited to share this part of the space. But of course, derived data corresponds to many different types of data in practice. And so here I've pointed to two general purpose repositories, because depending on the type of derived data you want to share, there might not be a repository dedicated just for that type of data. These general purpose repositories make it possible to find data set, to access them. It's a bit harder to find a data set because they are general purpose, so you will have less flexibility on the type of question you can ask. And then there is the question of, can I find an appropriate standard to actually share this derived data? And here I think there is two main directions. So the first one, of course, is to try and find an existing standard and database, and FAIR sharing is a nice website for that. So it might help you identifying standards that you don't necessarily know about. And if there is none, then possibly you're the best person to help develop the next standards. So BEADS in the past couple of years has been extending from raw data into derivatives. And there are a number of BEADS extension proposals that are open right now, looking for contributors, or you might want to start your own if the type of data you're working on is not covered yet. Another approach to this, because derived data is such a large space, sometimes it's difficult actually, even within BEADS, so having efforts in BEADS, sometimes it's difficult to say, well, is this metadata crucial for reusability, yes or no? Sometimes we just don't know. And so we have this effort called BEADS Prov with Satwa Ghosh, where, and of course many other contributors, where the idea is that instead of deciding which metadata are common and have to be reported for a given type of derived data, we are going to just give a full description of the provenance. So the provenance is really the history of the file. You have an example here going from raw anatomical data to pre-processed anatomical data, and same with fMRI. And so basically describing all those steps so that we have a complete description of the history of this file. And we think that this can be useful for multiple reasons. And in fact, there are many scientific communities right now are getting interested in provenance and in recording provenance. The first situation is, well, of course, to have an unambiguous description of the method. So if you've tried to reproduce the paper, you probably realize how hard this can be. We often face many questions that are left just unanswered. So there's the question of being able to reproduce exactly the same results. So that's what we've just touched upon. But then there is also that question that sometimes variations into that pipeline are going to make changes in our results. So for instance, maybe for a few years, there was a practice that was considered as acceptable. And then one day the research community, the knowledge of the research community makes it no longer a best practice. In that case, it would be extremely useful to be able to go back to the literature and say, okay, that study used that parameter that we now know is an optimal. I should read the results with care. And again, another version of that is, well, a bug was found in the software. And this is not just for neuroimaging software. Any piece of software can have bugs. And therefore, being able to go back and say, okay, this particular study used that version of the software that we know had a bug is extremely important. Another aspect of that is the question of analytical variability. So there is increased understanding in the brain imaging community that the exact steps that we applied on the data set might have an impact on the results, but it's hard to know what changes in the pipeline actually do impact. And so having a complete descriptions might help us understanding throughout the literatures, finding patterns of particular factors that have a strong effect. So BeatsProf will soon be open for community feedback. If this sounds that's something you'd be interested in contributing to, please do. The link is just here on the slides that will be shared. And so here we had an opportunity to share our derived data. And I'm going to stop here and thank everyone. And I think there will be time for questions.